Modeling and control of a proportional valve for medical air supply applications is a fresh project, which was initiated with the exponentially grown demand for mechanical ventilators during the pandemic situation. This project is focused on building a performance-enhanced prototype ventilator. Mechanical ventilation, referred to as artificially performed inhalation, is the administration or support of respiratory functions from outside the body, with the help of specialized machines. Those machines are called mechanical ventilators, and one of the main components is proportional valve. This project offers a controller which controls the proportional valve in a closed-loop system. The controller gets an input pulse train of predetermined flowrate pattern with preset amplitude. The output flowrate of the valve is feedback into the controller through a sensor. The first part of this project includes deriving the plant transfer function and designing the controller in order to obtain predefined characteristics and specifications. In our project, the main objective is to open the proportional valve as soon as possible for respiratory process. General assumption is that the valve should open at least in 0.1 seconds. Therefore, it is taken as the rise time of the control system. Our objective is to design a controller for the proportional valve so that the rise time of the system is below 0.1 seconds and an overshoot with under 5%. The transfer function of the proportional valve had a rise time of 127 milliseconds and an overshoot of 58%. The performance of the proportional valve is not sufficient for the prototype ventilator. After adding a tuned PID controller, the closed-loop system resulted a rise time of 89 milliseconds and 4.7% overshoot. Now the selected proportional valve can be used. Second part of the project basically covers the hardware implementation of the designed controller model with the aid of digital sensors and microcontrollers. These are the hardware used for the implementation. This demonstration shows how the output flow rate of the controlled valve varies with the input. First, the breaths per minute, which is called BPM, is kept as 12 and the inspiration to expiration ratio as 1:4. Then the ratio is changed into 1:5 and the BPM into 20. 20 is the maximum BPM we can achieve from this controller without distorting the input pattern. We can see the controlled output follows the input pattern of the flow rate considerably. We can conclude that the outcome, after adding a closed loop with a PID controller, is an output signal which almost perfectly follows the input flow rate pattern. Therefore, the objective of the project has been reached with the expected performance.